All right, so go ahead and turn the page, and you should now be where I'm at right now on your notes. So in example 1, which we did together, we saw that x minus 2 was a factor of the polynomial, okay? And the long division process produces a remainder of 0. Often, though, long division will produce a non-zero remainder. All right, so it's not always that you're going to find the right factor that's going to give you a remainder of 0. So just like we had like in example 2, this is just another example now. If you divided x squared plus 3x plus 5 by this binomial x plus 1, you would obtain the following. Okay, so here's all the work right here. Now here's some nerdy vocabulary. When you divide the expression that is underneath the division, it's called the dividend. Okay, so you could actually give this a name instead of saying, oh, it's the stuff underneath the house. Okay, that's like maybe you learned that in elementary school or some of that, but the actual word right here is dividend. Okay, that's what the numerator number is. Then what you divide by, or the denominator, okay, then you would call that the divisor. Your result is called the quotient. So once you divide the numerator by the denominator, that's called the quotient. And then lastly, that's called the remainder. All right, and in fractional form, it's right here. So it's the same terminology, just now written in fraction form. The dividend divided by the divisor equals the quotient. And then when you write your answer, you put plus the remainder divided by the divisor. Okay, all right, let's go on now to example number 3. Notice the stuff that I wrote over here on the right-hand side. Before you do the division algorithm, which is just what we've been doing, I just gave it a nice fancy name, division algorithm, you need to write the dividend and the divisor in descending order. Meaning, if you were to be given a problem, something like this, x to the power 3 plus 4x squared plus 5x to the power of 4, and then if you divide that by x plus 4, what you would want to do first is actually write it like this, right? 5x to the power 4 plus x cubed plus 4x squared, and then you're going to divide that by x plus 4. Okay, so that's where you're going to write these in descending order, from the highest exponent to the lowest exponent. And then also at times you're going to need to insert a placeholder. That wasn't the original bell, so don't get up and start leaving. You're going to need to insert the placeholder with the 0 for the missing coefficients, or for the missing terms. So for example, to demonstrate that, say if I gave you, well actually I'm going to demonstrate that right here in example number 3. So let me just go ahead and just dive into this guy. And there's the announcements. Let me pause that. All right, let's continue now. The announcements are over. All right, so what we want to do here is that we're going to divide x to the power 4 minus 1 by x plus 1. So what I'm going to do is I'm going to make sure to insert placeholders with 0 coefficients for the missing powers of the variables. This is what I mean by that. All right, so when I write this, x plus 1 divided by, like I'm going to write x to the power 4. Notice that there's no cube term, square term, or x term. So I'm going to put plus 0 x to the power 3 plus 0 x squared plus 0x minus 1. Meaning that there should always be a term, or at least a placeholder for every term of every degree. So like if I have a fourth degree, then that means that there should be a third, 2, 1, and then our constant number there. All right, so now let's go to town on this and let's see how we do. X times what is x to the power 4? Well, wouldn't that be x to the power of 3? And let's multiply. X cubed times x is x to the power 4. X cubed times 1 is a positive 1x cubed. Okay, let's go ahead and subtract these guys right here. So that's going to become a minus, and that's going to become a minus. And so those are gone, and so now we get negative x cubed. So now let's go ahead and do this again here. X times what is negative x cubed? Well, wouldn't that be negative x squared? X times negative x squared is negative x cubed. And that means 1 times negative x squared is a negative x squared. Okay. Drop this down right here. Plus 0x squared. All right. Let's go ahead now and subtract these guys. Hey guys, don't try to creep right now. Don't try to creep. All right. Let's change all the signs. So it's going to become a positive, and that's going to become a positive. So that means that those cancel out, and I get just a positive x squared. All right, let's go ahead and try this again then. X times what is x squared? Well, that's just positive x. So x times x is x squared. X times 1 is a positive x. And we've got to drop down what we have there. So I'm going to... That's really horrible looking. Sorry. Plus 0x. Let's go ahead and subtract these guys. So this is very monotonous, meaning that it's the same process over and over and over again. So once you get the hang of it, it just repeats itself. All right. So let's go ahead and change all these signs. So minus, and so now we have negative x because those cancel out. We can drop this down and get negative 1. And let's do it one last time. X times what is negative x? Well, wouldn't that be negative 1? So negative 1 times x is negative x. Negative 1 times 1 is negative 1. And what do you know? If you change the signs right here, we get remainder of 0. Cool beans. So this is our dividend. This is our divisor. This is our quotient. And this is our remainder. So our answer is our quotient. X cubed minus x squared plus x minus 1. Okay? And just so that we are clear on what this means is if you take your answer, x cubed minus x squared plus x minus 1, and if you multiply that by the divisor, by what we divided by, x plus 1, that equals the original function. Okay, and that's the connection that you really need to make right now, is really when you multiply the quotient by the divisor, by the dividend, then you're going to get back your original polynomial.